Let's finish out our sensation and perception unit with talking about the other senses, the rest of our senses that we haven't talked about yet. The first senses we're going to talk about are chemical sense. The first is taste, the other is smell. Both of these are chemical senses because substances actually enter into our body. So chemicals actually enter into our body in order for us to sense either the smell or the taste of this. So the first one we're going to talk about is gustation. This is taste. This is a chemical substance because the food particles actually enter into our body in order for us to detect the taste, okay? So this is done through our papillae, and those papillae contain our taste buds. So these are our taste buds down here, and our papillae contain multiple of those taste buds, and these taste buds then make up our afferent nerve, or our sensory nerve, that then goes to the thalamus and then to our brain to be processed, okay? With our gustation, our taste buds here regenerate approximately every 2 weeks or so. And so people who are considered super tasters, which there are people out there, are individuals with more papillae. Therefore, they have more taste buds, okay? So they literally have more receptor cells in order to determine the taste. I feel like pregnant women have like multiplied the amount of taste buds. That's just me guessing. There's no research on that. I mean, maybe there is, but I'm just guessing. Anyway, the blue dye on this picture here shows the papillae that you can see on your tongue. Okay, the tastes that we have, there are considered 4 tastes. This is the traditional taste sensation that we've all heard of, right? Sweet, sour, salty, and bitter. However, there is some current research that has shown that there is at least another 5th sense of taste or taste sensation, and that's umami. This is that savory taste, brothy or meaty, okay? There's also some research showing that there might be a 6th taste, which is astringent. This is like a numbing feeling and a constricting of your throat. Unripe bananas, pomegranates, cranberries have this sort of taste. Okay, let's go to the second chemical taste, olfaction. Olfaction is smell. This sense is of the 4 that we have talked about so far, it is distinct because our sense of smell does not go to the thalamus first. It is the only sense that does not go to our sensory switchboard, the thalamus, before it goes to the other cortices to be processed. So our sense of smell, again, is a chemical taste. The odorants, or the air molecules, go into your nasal cavity, and those stimulate 5 million receptors that we have. And those are called olfactory epithelium. And those are responsible for detecting the different odorants, okay? And it's at the roof of your nasal cavity. So here's your nasal cavity in here, okay? And we can detect with these epithelium about 10,000 different odors. That's pretty crazy to me. These regenerate about once a month or so. The crazy thing about smell is that the smell is processed in our olfactory bulb. Okay, and our olfactory bulb is actually part of our brain. It's at the very bottom of our frontal cortex here. And if you notice on this next picture, our olfactory bulb is located about right here. Look how close it is to our hippocampus over here. Our hippocampus, remember, is responsible for memories, or a lot of our memories. And so our smell and our memory are very closely linked. Think about it. When you smell something familiar, it like automatically takes you back to the place where you've smelled that. My biggest example is a high school boyfriend I had. The cologne that he wore was so distinct that whenever I smell it, if I pass someone who's wearing that cologne, it immediately takes me back to my high school days when I was dating that guy. I guess great memories, but yeah, it's those memories. Maybe it's the smell of freshly baked cookies taking you back to your grandma's house, or the smell of your middle school, or whatever it might be. Maybe it will be the smell of the locker room here at CMH that'll jog those memories. Okay, so sensory interaction, we've heard this word before, or this concept, but we're going to talk about it again. This is the idea that one sense is going to affect another sense. Taste and smell go really, really closely together. If you've ever like had to taste something or eat something that you didn't like or you didn't know if you liked, you plug your nose, right? Because when you plug your nose, that taste is going to change because the smell of something is going to interact with how it tastes. It also the sight of things too. If something doesn't look tasty, you're not going to want to eat it, right? So that's why a lot of people can't deal with green ketchup because it might taste different to them because of the sight. Okay, so let's talk about our body senses then. The first we're going to talk about are our somatic senses. This is our sense of touch. Our sense of touch is a mix of 4 distinct sensations: pressure, temperature, vibration, and pain. So temperature is going to be a mix of hot and cold receptors on our skin that are activated at different amounts to determine what temperature we are feeling, okay? Pain is the sensation that is telling our body that something has gone wrong, okay? So usually pain is going to result from damage to either the skin or other tissues in our body. However, sometimes pain can be psychological. So there are times when pain can happen without actually a sensation happening. And we're going to talk about that in a little bit. But there is a rare disease in which a person can feel no pain. And this is known as congenital insensitivity to pain. And you might think, oh, this sounds like a great disorder. I'd never feel pain. It'd be awesome. However, it has some drawbacks, right? Like you can never feel if you have an infection or if you have a fever, or you would never feel if you broke a bone. So your ability to get injured or get infections is a lot higher because your body isn't telling you that something is wrong. Okay, so this girl on the right here, Ashley Blocker, she doesn't feel any pain or hot or cold. So she has to be closely watched at all times just in case she would hurt herself. So she is, her life expectancy is actually a little lower than other children because she can't feel that pain. So what influences our pain? Everyone's pain is different. You might experience the same injury that someone else does, and your pain might be like extravagantly more than someone else's. And that's because there is a number of different things that influence how we feel about pain. Okay, the first is that biological influence. The basic activity in your spinal cord or the interpretation of the central nervous system activity, and also the genetic differences in the amount of endorphins that you have in your body. But like I said, pain is also psychological. So if you're paying attention to the pain, it hurts more than if you're not paying attention. It's also based on your experience of pain in the past, right? Like the first time you got a paper cut, maybe you were crying like a little baby when you were maybe 5 years old. But now when you get them, it's like, oh crap, that hurts. But it's not like the worst pain you've ever felt. And then whether or not you expect pain relief to come. So if you are, in major pain and you know that someone's coming with some help, your pain might lessen than someone who knows that they will never have relief from that pain. And then finally, we have social cultural influences. So if there are other people around, you might experience more or less pain. If you feel for someone else, if you're in pain and you're feeling bad for someone else, maybe someone else is in more pain, you might not feel as much. And then also the cultural expectations that we have. Men might be culturally less likely to be told that it's okay to experience or express their pain. So they might feel less pain. Okay, let's talk about one of the theories about how we actually are feeling pain, how our brain actually interprets it. It's called the gate control theory. It was proposed by Melzack and Wall, and they said that our spinal cord has these neurological gates that either block, so are closed, and they block that pain, or they're open and they allow the pain to be sensed. And their proposal is that we have a neurotransmitter called substance P that is involved in transmitting the sensation of pain. Okay, so those pain messages. Substance P tells the gate to either open or close. Some evidence for this or support for this theory is the idea that like if you were to hit your elbow on a desk and then you rub it, right? You rubbing that elbow actually sends additional messages of pain to your spinal cord. So your spinal cord would open the gates for that sensation of rubbing your elbow and close the gates for the sensation of the pain from your elbow. So that's why the gate control theory has been proposed, because sometimes rubbing it, or like if you were to say like, oh, my tooth really hurts, and then someone punches you in the stomach, you know, that pain from your tooth is going to go away because those gates have been closed. We need to open them now for being punched in the stomach. Okay. Okay, so how do we process pain? Well, it goes multiple places, and this is important, so you need to write this down. So pain sensory input is first, like all of the other senses except for smell, it's first relayed by the thalamus. Okay, so at first, those afferent sensory neurons go to our thalamus. At that point, the thalamus sends it off to multiple places. Okay, the first is going to be the somatosensory cortex. This is going to be all of those sensory components of pain. So judgments about it, the quality or the intensity of the pain, the location of the pain, all of that. But it also goes to those afferent neurons go to the areas of the limbic system. These are going to be the emotional and motivational components of the pain. So your desire to get out of the situation or the immediate unpleasantness, sometimes it's going to make you cry, make you feel emotional, right? So it'll go to those limbic system. From there, from those two areas, it's going to go to our prefrontal cortex, the very front of our brain, okay? And this is going to be the secondary emotional and motivational components of pain. So our worry about it, is it going to leave us scarred for a long time? How much suffering are we going through? So those later on kind of thoughts of pain, okay? Okay, so we talked a little bit about the idea that sometimes pain can come without a real sensation or the simulation of pain, and that's called phantom limb sensation, or an example is phantom limb sensation, and this is when amputees actually feel painful sensations that seem to be originating from that amputated part, okay? So this is shown in Grey's Anatomy with Arizona Robbins when her leg was amputated. She felt pain in that leg that was amputated. This could be due to the cross wiring in the somatosensory cortex with nearby areas for the limb, okay? So our somatosensory cortex, remember, is going to have different areas of the cortex that deal with different parts of your body. So there might be just like a cross wiring or some of the same neurons deal with it. So the stimulation of that part of the somatosensory cortex is also going to stimulate a sensation in the missing limb. Okay, then there's two other pieces that we need to talk about, the body position and movement senses. Our sense of our individual body parts, where they are on our body, is called kinesthesis. Okay, this is an understanding of where your body parts are in regards to each other, right? So let's demonstrate this without looking. So close your eyes, touch your finger to your nose. It's not hard, right? That is because of your kinesthetic sense, okay? You did not have to continuously look at your nose or your finger. You just were able to do it. And the second is our vestibular sense. This is monitoring where the head is in relation to everything around you. This is your balance. Okay, remember this is located in the semicircular canals of your ear. It's that fluid, and when that fluid is off balance, then you feel off balance, okay? So it's knowing whether or not we are right side up or not,